Hello and welcome to the second of our panel discussions today, the digital transformation in manufacturing. This is the first of two debates looking at the current status of companies transitioning to smart factory concept. This panel will examine the digital transformation, which comprises, of course, machine learning and artificial intelligence, analytics, conditioning monitoring systems, predictive maintenance, digital twins, and augmented and virtual reality. Joining me today, I have remotely, we have Michael Ford from Aegis Corporation. Hello, Michael.
Hello.
Nice to see you.
Hi.
You're calling in from the US today, are you?
I am. I'm in Wisconsin.
Wisconsin. Oh, lucky you. Okay. Then to extreme left we have Keith Bryant, and then to my left here we have Harold Eppinger from Co-Young. So we'll get started, and I'll start off with you actually, Michael. My first question is, does the Global Smart Industry Readiness Index offer a potential level playing field for companies to assess their current position on their digital transformation journey and offer a roadmap for which areas they need to improve?
I had a look at this. Yeah. It's a very interesting document, actually, and it really addresses one of the key issues that there are when factories or operations are trying to go through digital transformation. Because, it's like, would you go out and buy a car if you'd never taken a driving lesson? Right. You're not going to get the best out of it. So understanding the readiness of your operation to be able to take maximum advantage of the digital transformation tools that you'd like to put in place is very important. Yeah. And, I do see in the market that those who are successful are those who have achieved a high level of this readiness.
Right. So, Michael, just for those of us that are not familiar with this particular project, or the Global Smart Industry Readiness Index, you've had a quick read through it. Can you explain exactly, what it is and the premise behind it?
It's really looking at where we are today in terms of the kinds of technologies, tools we have, and it creates a kind of maturity profile. So there are various different aspects that are being looked at, being measured and evaluated, and then going through and having a look at what is the current state of the factory so that you can go in and have a think about how you compare to that level, and you end up with a score. They call it a SIRI maturity score. So it's very interesting to actually go through and compare your operation with what is described in the document.
So, I mean, Keith, do you think in general that there's value in having a system that measures you and your capability for digital readiness, so that OEMs can maybe in the future say, well, we're putting a job out to tender, but you need to have a global readiness figure of or capability of more than 80, for example?
Yeah, I mean, I'd come at it from a slightly different angle, Trevor, and I'd say if it shows people what they have to do to move forward, then it's a great benefit, because that's what people need to be doing. There are some companies that haven't started, there are some companies that are moving along, there are unfortunately some companies who are just paying lip service to it, and I think if you have something that tells you basically where you are, the real important thing is it tells you where you need to go. And nobody's going to be scoring 10 out of 10 within our electronics industry today.
Right.
But if they're scoring enough and they think, okay, this is where we need to go to get to the next level and the next level and the next level, then it becomes a framework for growth.
Yeah, I mean, Harold, I think it's definitely potentially a good system for galvanizing people to make them start to pay attention to their digital transformation, because as Keith says, there's a number of companies haven't even started yet. So if they're listed on a league table, if you like, and they seem to be fairly low on that spectrum, then it's going to galvanize them to want to get it more involved and push their automation digital journey.
I think the most important aspect, and I agree to Keith, it's in the beginning as an advisory index to know what to do and where to go for. I see the people starting very often jumping into the digitalization and jumping in and not having done and executed the basics.
Right.
So they are catched later on a very critical moment that the whole picture is collapsing. So I think the index might be a good part, but I believe the guideline to go for, this is the basics, this you have to go through, and then you can utilize this. We see this process, but we are very often to the huge amount of data we are collecting in the manufacturing process, we are able to collect,
Right.
that it's not, nobody has learned to execute it, to realize it. Yeah.
Right. Okay. So I'll move on to my next question. I'll go back to Michael, and that is, should sustainability and security be considered as a key performance indicator?
These topics are obviously very important to a lot of customers, end users of products. So I'm seeing a lot more interest in this. Would it be a key performance indicator? It's tough to say because normally KPIs are kind of measured around quality or performance and things that directly impact the the cost and quality of the product, obviously. Whereas sustainability and security are not. However, you could think that, if there was a compromise in a product, such as a risk of a cybersecurity attack, that could compromise the product in terms of quality and performance. So kind of indirectly, there is a relationship. But I think, as we move forward, with people demanding more and more consideration of security and sustainability, the environment and those kinds of things, there will definitely be a measure. Whether it will be called a KPI, yeah, probably it will be. And will it be as important as other KPIs? Well, I certainly hope so.
You have any views on that?
Yeah, I pretty much agree with everything that Michael said. I mean, a lot of our stuff today is interconnected to everything. We have Bluetooth, we have Wi-Fi on just about everything, including a smart dog collar for our dogs so we can see where they are.
Yeah.
So, there's so much potential for hacking and damage and all the other things. So, yeah, I think, security needs to be taken in there. And, if the COVID thing has taught us something, it's, sustainability is becoming more and more important. So, yeah, I think, as Michael said, if they're not KPIs today, they should be soon.
Yeah. Okay. Question for you, Harold, and that is, because you're in the software business, of course, and are there any key differences in how software companies are applying deep learning and AI, and does the approach vary geographically?
I think it's right. It's everywhere, and you cannot oversee it anymore. That everybody has to use the AI, deep learning, machine learning, and we have seen there are some more and more intensive expertise in the different regions how to utilize it. That it will be applied worldwide, it's clear. But as you know, we have a R&D center in San Diego because artificial intelligence is much more common in US, and we utilize these expertise there. But following with other regions where they have a specific know-how.
Right.
So it's absoluteness, and you see it, it's executed, it's part of our complete software package.
I mean, but you obviously run the German division of a company, and in the European Union they're bringing out guidelines on how to develop AI, which I'm not particularly sure that everybody else is going to follow. Are you hearing anything about this?
Not directly, because definitely we are not developing software in Europe.
Right.
That's clear. But when I talk to our experts, they clearly say they have very good capabilities in the different regions. So there are some experts, and I'm wondering if we should say that it's just starting to reconsider how to do it.
Right.
This might be quite a little bit late for this industry, and maybe for our industry to utilize it. But then something is wrong, because there is no label without AI or deep learning here on the show.
Well, yeah, that's just a marketing thing. But I mean, what I'm getting at is that the European Union put together a panel of experts to decide on things. And one of the more controversial ones is that at the end of every decision tree there must be a human making a decision, which seems to fly in the face of having AI, I guess.
Oh, it doesn't seem to, Trevor. It does. It is what it is, and we go back to the fact that the horse designed by a panel came out looking like a camel. It's a dangerous thing, and sometimes you're better, to leave the experts to do what they're good at and develop what they develop. Because if you start trying to have panels within government to control it, effectively all you'll do is you'll handicap the people that are working in that country because they just won't have the same abilities as the people that aren't shackled by the same rules.
And I would like to add a comment. I think our generation is a little bit more afraid of automatic decision processes compared to the next generation, over next generation, because that's part of the life. I think the acceptance is different. I think we are more afraid, and we all know that maybe a machine will decide much more clever.
Yeah.
And we can have an autonomous taxi without a driver. Why can't we have an AI chain without a person at the end of it making the ultimate decision?
It's very true. I'm just pointing it out, raising it because it is out there.
Oh, yeah.
Okay, let's move on. Michael, can we expect to see more sophisticated condition monitoring sensors in the future?
Could I just answer the previous question a little bit? Sorry. For the AIs, we have to think about the level of AI, because there are AIs making decisions all the time without anybody taking any notice whatsoever. It's the big kind of decisions in AI that are the things of concern in the European Union. What we are seeing in manufacturing, let's just base it in manufacturing, is we see a lot of niche players, machine vendors doing machine learning, things like that. Academia, there are many different projects which we are invited to participate in, where they now suddenly have access to a huge amount of data coming from the shop floor. They would like to use that to create some kinds of decisions for planning or maintenance or things like that. And it's amazing stuff that they're doing. But the problem is, what do you do when you've got to a conclusion with that AI software? How do you then kind of action that into an MES solution and therefore onto the shop floor? So what we're looking for is a kind of ability to rationalize those decisions, plan them, get them put into the minds of the people in manufacturing so that they can either accept, modify, or reject those major decisions that are made by those AIs. So you will have a kind of distributed AI technology arena where many different algorithms are working all over the place, doing different things, analyzing data in different way, and bringing those conclusions together at the point of use, which is in manufacturing, which is managed through MES. So I think from the MES perspective, this kind of European directive is not going to have a huge amount of issue, simply because they are relatively small decisions, less dangerous, I guess, and there will be this MES layer that is used to manage the execution of any actions that are taken as a result of AI decisions. So I hope that makes sense. Just to go on to the next question about sensors. There is another revolution going on, of course, because we see autonomous robots being able to touch and feel things. But there are a lot of new sensor technology being introduced, and this is great from the perspective of things like predictive maintenance, where instead of having to go and touch a motor to see whether it's running too hot or vibrating or doing something it shouldn't, we can now start to measure that, like the current patterns that it's using, or a record of the vibration and the heat in that motor, so that information can flow through to, an AI, who would then look at that motor and think, I need to make a decision to replace that motor at the end of the current production so that I don't disturb anything, and then I will instruct that spare part to be introduced, set up, next production works fine. So these kinds of sensors are really enabling that kind of automation of things that we used to sense with our hands.
Great. So, Keith, people have been talking about predictive maintenance for a while. Are people actually using it at the moment, and to what level?
But people have used predictive maintenance for a very, very long time, Trevor. Not so much in SMT, but in semi. And I'm completely in agreement with Michael, and I know that this gentleman on my right will be as well. The more information that you get from your machines, the more you can put it into a central, let's call it, control area, the more intelligence you have in your system.
Yeah.
And the ultimate predictive maintenance is you shut the line down at the same time every month, and you do everything that's needed, and the next day you fire it up, and for the following month it runs 24/7 without missing a beat.
Right. Yeah, I mean, there's different levels of predictive maintenance. There's people that are, there's predictive scheduling, as you're saying there, making sure that the maintenance is done when the lines are down and not interrupting the production process. But then there's the other types of predictive maintenance where they're predicting the expected life expectancy of a motor or a belt or something like that.
So, but sorry if I can jump in, Harold. That's the information that goes to the central database, and they decide if that motor isn't going to last another month, we're going to change it today. We're not going to predict that it's going to last another 3.5 weeks and change it in 3.5 weeks because we don't want the line downtime. What we want to do is to shut the line once for a day, do everything that's going to go wrong within the next month so that there's no meantime between failures, there's no unplanned failure, there's no unpredicted failure, there's nothing apart from a perfect routine running. So it's a matter of using that information that, this motor is only going to last another 2.5 weeks, probably, so we'll change it at the next downtime, which is in a week.
I would like to add here some learnings. We're always talking about the predictive maintenance, which includes a shutdown of a line. But with the information of things which are not working proper, you can even go for a dynamic change. You even don't stop the line, you change the nozzle, you do something like this, you change the stencil. And this is extending the real downtime to the later time. So dynamic exchanges is also predictive maintenance because you predict the exchange in a time without shutting down. And I think this is a two aspect of predictive maintenance. We know that something is going wrong and will go even worse.
Right.
And then we start the process and to trigger the process.
Okay.
Yeah, you see, I'm going to, much as I hate to do it, I'm going to disagree with Harold. That's not maintenance. That's fixing your production line to keep your yields where they should be. And for me, that's a different animal. And
to keep the nozzle.
No, you change it. If your machine says the vacuum's gone on this nozzle and all these components aren't where they should be, you've got to change it there and then. But that's not what I would look at as maintenance. That's something to improve your yield. Maintenance is to keep the machines running so they don't break down. Yield is to keep your production at a level where you want it to be. And it's a little bit of semantics, but as Harold said, those are the things that go on all the time. Yeah. Their SPI machine says we've got insufficient, so you're going to clean the stencil. And that's within the realms of production to keep the yields up.
Right.
I see where you're
coming from.
Can I sort of just add here? 'Cause I agree with both of you, just so there's no fighting. But Harold has a great point, actually, because if you can perform any maintenance job, I mean, the difference between the two point of views is one that is for kind of consumable items, if a nozzle could be considered consumable, something that is changed through a process of automation, which doesn't disturb the line at all. So Keith's point about yield is true, that's fine, but it is a maintenance job, and it's a routine maintenance job, and it's automated, and it's perfect because it's not impacting the line performance at all. And then what Keith is talking about more with the motor example that I mentioned is a kind of more serious thing where something that should be lasting like 1, 2, 3, 4, 5 years is going to be failing within the next month or two. And, the scenario that Keith painted around that is absolutely perfect, so that you can manage that kind of change of device or component in a time that was already going to be, not added value time of the machine. So therefore, you've not lost any performance in production, and you've not risked that machine breaking down abnormally, which would be a huge disturbance to manufacturing. So you're both right, guys, and that's the good news.
Okay, Michael. For me, predictive maintenance is something that you predict is going to happen within a period of time. If you get feedback from an AOI machine that a nozzle isn't working, that's not predictive, that's fix it now.
Oh, no, I mean, I don't say that the nozzle isn't working, but the software now that is in use, and Harold will probably say something about this, you can start to chart, through analysis of the data, the performance of the nozzle such that you can start to do that replacement before you have a negative impact. So it's exactly the same algorithm. It's simply avoiding, rather than a breakdown, which a motor would represent, but this is a breakdown of quality, or so that would have some impact. So it's the same principle, but definitely not waiting for the problem to happen. The predictability is the knowledge that the problem could happen very soon and avoid that situation. Harold, is that right?
Good. Well, thank you for that. So I think we'll move on to the next question now. And I'm going to look at the topic of virtual reality, because we are talking about smart factory digitization here. You have virtual reality and you have augmented reality, but virtual reality is still being touted as a strong training tool. But current systems cause dizziness or nausea after 20 minutes. You can only wear these goggles for 20 minutes. Is this likely to change, or is augmented reality the only real alternative? Harold.
So we implemented the tools now from headquarters. We have customers are using different models. They prefer the Google, they prefer this application, that application. We cannot justify and really decide, so we have to implement the infrastructure that we can handle it. Especially the last 2 years showed us that it's very important to have this kind of tools, because we could not go on site to fix things, and our distributors could not fix the on-site. So yes, it's changing. It's improving. If you see the first level of releases and you see the today's level, it's a totally different story. And I think it's everywhere, and it's very, very useful.
Yeah. Okay. Michael, I believe you're firmly in the AR camp from the offerings that you have at Aegis. Am I correct?
Mm-hmm. Oh, yes, absolutely. Augmented reality is nice because it is relatively inexpensive. You are seeing the actual field of view, and you're seeing information come up to guide you what to do next. And, this is not just for training. This is actually for normal operations. So we're recording traceability and actions that are taken. So it's a fully interactive environment. If we were to look at things like mixed reality, which are in fact getting a lot better now. I mean, the technology is moving on hugely. I mean, I saw a demonstration recently where, somebody could just put on one of these headsets, go to a machine, start opening things up, turning things off, dismantling heads and things. And, it's amazing. I felt that I was now empowered myself to be able to go and do that properly without destroying anything. I wonder, though, whether that specific use case goes beyond training, because I remember with operator instructions in the past, you would kind of learn what to do, and pretty soon having to look at the instructions got in the way. And I think even these mixed reality portals, and certainly the VR portals, they're going to get you up to a speed very quickly, and then you just want to get rid of that as a distraction, because you know what to do, you know where things are, you know how things are supposed to be, and you just want to do it. So again, that goes back to the fully interactive nature of AR, where you're less focused on giving people information about what to do, and you're more focused on making sure that that is all executed correctly, so that you're collecting the traceability information.
I think you're right. I think it's used as a troubleshooting tool as well, for absolutely sure. Well, we're running out of time here, so I'm going to very quickly go to my last question, starting with Keith. Very quickly, what more can you each offer manufacturers to hasten or improve their digital transformation? What is the one thing they could do?
It's feedback from sensors, and it's acting on that feedback. And it's really as simple as that. As other people have said here, the machines are getting cleverer. The machines are getting more data coming out of them. We just need it all linking together and controlling, and then we'll move step by step to being a lot smarter than we are today.
There you go. Excellent advice.
I think the key is the visualization of all the data, the outcome, and to build up the trust on the decisions.
Right.
I think that's our way.
So visualization of the data, but you also subscribe to the idea of collecting all the data, any that you can, whether you need it now or not, because you might need it tomorrow.
You need it in the background. It's not that you need it now, but you need it for statistical prediction, all these kind of things. You have to have the history that you can predict the future. And you have to prove the decision process. What happened today, how can it happen tomorrow, and how will it happen tomorrow? And I think that's the world of the digital twin perspective.
Great. Okay. Last word to you, Michael.
Okay, I would like to take it back to where we started. We started with this Global Smart Industry Readiness Index, which, was allowing people to assess where they are in terms of being an organization. What I would see as the next step after that is what I call the AIQ assessment. We all talk about the human's IQ, how clever we are, how smart we are. Well, how smart is your factory? How do you know that you're making the most out of the data? Or how do you understand what opportunities are there and that you're taking maximum advantage of them? So we've got a little thing where we go through and help people to understand what data is available, how that data is used, how it should be contextualized, so put together with many other pieces of information to create facts that can then be used to manage production in real time. So that AIQ assessment is a really, really interesting way of determining how smart you are right now, where you would like to be in the future, and highlight what you can do in order to get there.
That's very sound advice. I think it's a great idea, this global index, and I think it'll certainly be something that will be seen developed in the future. Anyway, we've run right out of time. They're switching the lights off here, so that's going to be it from Nuremberg for today. I want to thank our guests, Keith Bryant from Keith Bryant Consultancy, Harold Eppinger from Co-Young, and of course Michael Ford from Aegis Corporation. So thank you everybody, thank you for watching. Sorry about some of the time frames today. We're going to try and get everything back on schedule tomorrow, so make sure and tune in tomorrow for some more live streaming from SMT Connect.
Thanks everyone.
Thanks. Bye.
Bye.
Co-Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionize the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Co-Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think PulseForge.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.